Hey, welcome back. I have some footage about working with sheet metal, and it doesn't tell a very coherent story, nor is it a complete story, but I think it has some interesting points to it, so I'm going to show it to you anyway. And it's mainly about spring steel. This is 14310 spring steel. Already comes spring hard. And this is a stainless quality of a spring steel. Doesn't rust. And there are some things that you need to consider when you work with spring steel. For example, cutting it with shears can cause problems. And drilling is not that easy, and just a little bit more. And also I want to show you a tool acquisition. So let's start with this. Okay, I need to cut some strips of 0.5 millimeter stainless spring steel. That's 14310 spring steel. Comes already in a spring hardness, and you can shear it with a fairly heavy-duty bench shear. You can cut this stuff. I have one, but the strips I'm cutting need to stay straight. And shear cutting always introduces stresses into the edges of the strips, and they tend to twist along the length. So next best, abrasive cutoff. I set off a pair of 1-2-3 blocks on my magnet chuck. I have a strap clamp here. That's basically the fence where I'm pushing my stop up against. And I have two strap clamps that I can move to hold the stock down. I have a thin angle grinder cutoff wheel here and the spindle, and we're just marching through there. And that's a nice distortion-free cut. Almost no heat input. This is again one of the Cubitron 2 wheels from 3M. I don't get money from 3M, unfortunately, but these are the wheels that I use. They work excellent, really. 1 millimeter thickness, and it's a 125 millimeter. Fits my surface grinder quite nice. So undo those two screws. Pull back the strap clamps, and there is our strip of material. Works really well and fast, as you have seen. Usually you can get away with shearing them and then milling or grinding the edge. Usually that takes the stresses out and the strip kind of straightens out, but it's not that much more effort to do it this way. Plus, I don't like cutting hardened spring steel with my bench shear. It takes its toll on the blade. While we're working with spring steel, I can also show you how I mill them to size. I need them to be 5 millimeters in width before I bend them. And I could surface grind them to width, but I'm more proficient on the mill than on the grinder, and I'm just faster on the mill usually. So I'm milling them. Set up 2 parallels down here, so the strip shows up above the jaw. And a second parallel, a third parallel, a narrow one, to push it up against the fixed jaw. Otherwise, a single parallel down here would be too thick. These strips are only 0.5 millimeter, and I don't have 0.4 millimeter parallels. I have a bunch of sets of very thin parallels. These are 1 millimeter thick. Abrasive cut out of 1 millimeter shim stock, and then surface ground parallel. But being 1 mm thick, even those are too thick to hold the 0.5 mm strips. I'm using a 6 flute 6 mm carbide end mill. You need basically a carbide or at least a high-speed steel end mill that's coated to mill the spring steel in a hardened state. Otherwise, a normal high-speed steel end mill will not last very long. Running at 3000 RPM and taking about 0.3 mm. I cut them about 0.6 mm oversized, so I have 0.3 to clean up on each side. Before you flip them over to mill the other side, you need to deburr them. A relatively coarse silicon carbide stone works very well. It cuts very aggressive and very fast. The edges will get a proper finish after I cut them to width and size anyway. I needed to do some sheet metal work on very small parts. And with sheet metal in my world, that's prototyping mainly on small parts. It's way smaller than my hand. And I don't have a good way to do sheet metal bending and shearing. I have a large bench shear. That's good for sheet metal up to maybe 3 or 4 millimeters, but it's not a very precise way of cutting. And I don't have a good way to bend precisely at all. I have a V-die and a blade that I can use in my hydraulic press, and some smaller parts I bent in just in the vise with a piece of wood and bending it over. But I needed something better. First I was looking at those 3-in-1 brake shear rollers that are made in Far East and seem to be very popular, but those seem to be more for body panel work, car sheet metal, stuff like that. They seem to be a little bit too clunky for what I want to do. I needed something that can do work more in the realm of machinist tolerances. And what I ended up with is a Swiss-made Profiform 200. 200 is the working capacity. Width. It's only a shear and a brake. It cannot roll. It's a quite nice design. It's cast frame. It has a brake down here, lever actuated. The die, the upper die or blade, whatever you want to call it, there is a 200 millimeter long one that goes full width of the brake, and there are segments that you can use if you have to do something like a closed shape or something with a lip standing up on its side. And it comes with one V lower die, large and a small V. The shear up here is very simple made. It's two square high-speed steel blades. That means that they're easy to resharpen. Just grind them on the surface grinder. And 200 millimeter is also the working length of my surface grinder. There's a second version of this machine that can do 320 millimeter working width. And this shear is really for light duty work. It states that it cannot cut up to 1 millimeter in steel and 1.5 in aluminium, but I tried 1 millimeter steel and it works. It cuts very nicely, but it doesn't feel... It's definitely the upper limit, maximum material strength that you can cut. But 0.5 millimeter steel and 1 millimeter aluminium works exceptionally well. And that's more the range of what I needed to do. I need to cut usually very thin sheet metal. I need this to cut 0.1 millimeter brass shim stock without a heavy burr, or 0.2 millimeter German silver, or 0.75 millimeter aluminum, stuff like that, just very thin, or even some heavy-duty paper stuff. Even that's sometimes in prototyping. The brake, this will break 1 millimeter steel without a problem on full length. That's really, that works better on its max capacity. Robin Ranzetti mentioned to me that the limitation in cutting width might be that the blades flex outwards under the cutting pressure. So I'm already looking into putting a strong back on here so the blade doesn't bow out under the cutting forces. It's supported in this direction, and the fixed blade is supported in 2 directions too, but in the upward direction this is not very stiff, so I might add a stiffener here too. But that's for the future. The brake really works well. Used it already for a customer job making leaf springs out of 0.5 millimeter stainless spring steel. This is half of one of those spring steel, of those leaf springs. I'm not going to show you the full part because I'm not sure if I'm allowed to, so this is just a C shape in 0.5 millimeter spring steel, and the tolerances are really good. So this leg height here should be 11.5 millimeters, and after some filling with the backstop, I can bend to to machinist tolerances with this guy. And it's repeatable too. You also have a depth stop for the blade, so it always, so you don't overstress your material that you bend on. The lower die comes out like this. It has a backstop that's adjustable. I usually put in gauge blocks to adjust it, or I use a steel scale and measure to the front edge of the die. The die and blades, those are cold drawn profiles, which I was quite surprised that they went through the trouble to have a special profile drawn for this machine. I don't think that this is a high volume produced machine. And yes, they are definitely still made in Switzerland. There is a Chinese copy of it that's about a quarter of the price. But in this case, I didn't want to buy a project. I needed something that works right away. So that's the lower die with the 2 V cutouts. And this just sits in a slot down here. Nice thing is, this thing is light enough so I can take it off the bench and drop it in a drawer if I don't need it, and set it up within minutes if I need to. I already made a small table in front here, just an aluminium L shape that clamps here. The threads are already there, and I can, for example, use a parallel and a small clamp. If I need to bend on an angle. So you can go in like this on an angle. If you need to bend for whatever reason the end of a part like this. Or I can use a block against the blade, square a parallel up against it, clamp it, and do square bend like this. And this really allows to work quite fast, and with cleverly set up stop blocks you can do really a lot. I consider adding a dial indicator to the backstop. I have a nice large Mitutoyo digital indicator that I might put on there. And also I want some kind of a stop for the shear up. The shear really works nice. So you put your part in. This is 0.75 millimeter aluminum, so it's not really hard to cut. But it will cut a very thin strip without a problem. A very narrow strip. like this, without crazy distortion. The lower, the moving blade is at an angle, so it's a dragging cut. Otherwise you would have the full cutting force of the whole cutting length at once, and that would overstress everything by a large amount. And with the blade at an angle, you only are shearing the material in a small area at once. That allows for a very light cut. The blades on this thing came from the factory set, basically right on point. This is normal 80 gram per square meter paper, and that's always a good test. If you need your copy paper burr-free cut. Or this is PEEK foil, shim stock. Also, no problem. Perfect for precisely cutting that stuff. 0.1 millimeter brass. Perfect. So that's really a very nice tool, and you can be sure to see this in the future more. There are accessories for this shear brake combination. You can remove the blades completely in the lower die and put in, for example, a corner notcher that allows you to cut out a square corner of a part. There are also small hole punches, round and square. A corner rounding tool. There are a lot of things for this small press. So, and I will make own accessories for it too. So I have this piece here. This is 5 millimeter wide, 0.5 millimeter thick spring steel, and it needs to be bent in a C shape. And I already put the first bend in, and now I need to insert it like this and bend it. But the problem is, when you do this and the part goes up during the bending process, it will interfere with the backstop. And my make-do solution for this is, on a CNC press brake, the backstop would move out of the way when it actually bends. I do it similarly. I put the part in. I have a parallel here, and I set the stop, of course, with taking the parallel into account. So I push the part up against the parallel, and I bring down the blade, so it makes a little bit of contact with the part, so the part is clamped, doesn't move. And I take the parallel, and I take it out. Now when I bend, boom, the already bent leg of this C shape can clear the backstop. So here is the C shape, and when I bring in a caliper and I measure it, drawing dimension is 11.5. So this is 11.52, pretty close. Should be good enough. This is a part out of spring steel. It's bent, and now it needs some holes drilled into it, but drilling spring steel with a high-speed steel drill is possible, but it's not ideal. I showed a technique with very low speed and a backer piece and a thin web drill that works okay, but my preferred method to drill spring steel is either a carbide drill, which works nice, or even better, a carbide ball end mill. These work exceptionally well. The blue tape is here so you don't see the rest of the part. To drill with the carbide ball end mill, you use it just like a regular drill. Works only on thin material, maybe 1 times diameter the end mill. But spring steel usually comes in relatively thin thicknesses. They're also useful to drill out old or broken tabs. The ball shape gives it a fighting chance of not chipping immediately. Running quite fast and feeding relatively careful. Leaves a very clean hole, very precise on diameter and very little work to clean it up. When you bend sheet metal, you need to consider the direction the material was rolled. On spring steel, it's quite easy to identify the orientation which the material was rolled, because it usually comes as a strip and gets rolled in the direction that the strip is manufactured of course. And also the corners are usually, they have an edge treatment. They roll the edges over to make them burr-free and round. So the idea is you have your rolling direction. It's this direction, and it always gets called like a grain structure in the material, and I don't like that term too much, but I will go with it. Let's call this the grain, just like a piece of wood would have a grain, completely different but the same. And if you take a piece of wood like this one, where the grain direction is this way, it breaks relatively easy when you bend it in this direction. This is still too thick to break by hand, but you get the idea. If you bend it too much in this direction, it will break. If you put the bend line square to the grain, like this, it's much stronger. You can go much farther before the wood breaks. That's different for the direction you go with the steel too, when you bend it. If you bend a piece of spring steel like this, so the bend line is in line with the rolling direction, it will break. You want your bend line in steel to go square to the rolling direction like this. But hey Stefan, I need a part that has two bends that are 90 degrees to each other. Well, that's a problem, but you always can cut piece 45, and then you can put your bend lines in like this. It's less ideal than having the bend line 90 degrees to the rolling direction, but better than having them in line with the bending direction. That's a lot done with stamped parts that get die cut out of sheet metal and then bent. Mass production parts, that is. I have three pictures here. The first one, this is a bend where the bend line runs 90 degrees to the rolling direction of the material. And you can see the material is a little bit stressed and deformed, of course, because bending deforms the material, but there is no cracking. Then we have picture 2, where I put the bend line in line with the rolling direction. And you can see small cracks along the bend line, and that's a problem. This will fail. This is basically already a fail right out of the box. This will not last very much cycles or break immediately when loaded. And another thing to consider, here in picture 3, I used a scribe to put a scribe line into the material and used that as an orientation for bending. Don't do that. The material will break exactly at the scribe line, because the scribe line is basically a stress riser in the material, and it will break, especially in hard materials like spring steel. Or less ductile aluminium alloys will also crack at a scribe line. Use a soft pencil for layout on bent parts. Here you have a piece of aluminium, and when we look at it, you can see that the rolling direction of this sheet of material is this direction. It's rolled like this, and you can barely see that by the surface structure. If you have a material that is has a brushed finish, that doesn't work. Then, well, that's a problem. But if you can see it, there you go. You would preferably bend this material, put the bend line like 90° to the rolling direction in this case. If you bend it along this line, it will very likely crack. I hope you enjoyed this mishmash of little sheet metal techniques and a quick look at the Profiform 200 sheet metal brake and shear. I want to give a shout out to my friend Alex. He has a YouTube channel, An Engineer's Finding. I will put a link in the description. Definitely check out his videos. He put out a lot of content in a recent time, and he is an engineer who also is very practically. He's basically a practical engineer, not to confuse with practical machinist. That's a whole different story. He recently built a large-scale sheet metal brake, and he showed it in one of his videos very recently, and it's just a thing of beauty. So go check out Alex's channel. And that's it. Thank you all for watching, and I'll be back.